Hello students, today we are discuss about some notes of operating system. Firstly, we will discuss types of operating system. First type is batch operating system. Batch operating system is a set of similar jobs are stored in a main memory for a execution. A job gets assigned to the CPU only when the execution of a previous job completes. When execution of previous job completes, then we get assigned to the CPU our next job. Next type is multi-programming operating system. The main memory consists of a job waiting for a CPU time. The operating system selects one of the process and assign it to CPU whenever the executing process need to wait for any other operation like IO operations, that means input output operations. The operating system select another process from the job queue and assign it to the CPU. This way the CPU is never kept idle and the user gets the flavor of getting multiple tasks done at once. In multi-programming there are multiple tasks done at once. Next is multitasking operating system. Multitasking operating system combine the benefits of multi-programming operating system and CPU scheduling to perform quick switches between jobs. The switch is so quick that the user can interact with each program as it runs. That means we can use multiple multitasking operating system. Next is time sharing operating system. Time sharing system require interaction with the user to instruct the operating system to perform various tasks. The operating system respond with an output. The instruction are usually given through an input devices like the keyboard. Next is real-time operating system. Real-time operating system are usually built for a dedicated system to accomplish a specific set of tasks within a deadlines. Next we will see thread. The thread is a lightweighted process and forms a basic unit of CPU utilization. The process can perform more than one task at the same time by including multiple threads. A thread has its own program counter, register set and stack. The thread share resources with other threads of the same process, the code section, the data section, files and the signals. A few thread or a child process of a given process can be introduced by using a fork system call. A process within n fork system call generate two and one child process. There are two types of threads. First is user thread and next is kernel thread. The examples of threads are Java thread or POSIX threads. Example of kernel thread is Windows Solaris. User level thread. User thread are implemented by a user. Kernel level thread. Kernel threads are implemented by operating system. That means user level is implemented user, but the kernel level the thread implemented by operating system, it is a kernel level thread. Operating system doesn't recognize user level threads, but kernel threads are recognized by operating system. Implementation of user threads is easy, but implementation of kernel thread is complicated. Context switch time is less, but context switch time is more in kernel level thread. Context switch require no hardware supporting user level thread, but hardware support is needed in the kernel level thread. If one user level thread perform blocking operation, then entire process will be blocked. But in kernel level thread, if one kernel thread perform a blocking operation, then another thread can continue the execution. Now we will discuss about process. A process is a program under the execution. The value of program counter, that means PC, indicate the address of the next instruction of the process being executed. Each process is represented by a process control block. Now we will discuss process scheduling. Below are the different times with respect to a process. First is arrival time, second is completion time, third is burst time, fourth is turnaround time. Time at which the process arrives is in a ready queue. Second is completion time, that means time at which process completed its execution. Next is burst time, time required by a process for a CPU execution. This is called burst time. Next, turnaround time, that means time difference between completion time and arrival time. This is called as turnaround time. The formula is turnaround time is equal to completion time minus arrival time. And fifth is waiting time, that means WT, time difference between turnaround time and burst time. That means waiting time is equal to turnaround time minus burst time. Why do you need scheduling? A typical process involves both IO time and CPU time. In a uniprogramming system like MS-DOS, time spent waiting for IO is wasted and CPU is free during this time. In multiprogramming system, one process can use CPU while another is waiting for a IO. This is possible only with the process scheduling. There are some objectives of process scheduling algorithm. First is max CPU utilization. That means keep CPU as busy as possible. Next is fair allocation of CPU. Next, max throughput. That means number of processes that complete their execution per time unit. Next, minimum turnaround time. That means time taken by a process to finish a execution. Next, minimum waiting time. That means time for which a process want in ready queue. And next is mean response time when a process produce first response. Next is different scheduling algorithm. There are multiple scheduling algorithms. First is first come first serve. Next is shortage of first. Next, shortest remaining time first. Next, round robin priority based scheduling, highest response ratio. Next, HRRN. Firstly we will discuss about FCFS, that means first come first serve, simplest scheduling algorithm that schedule according to arrival time for a processes is called as first come first serve, that means FCFS. Next is shortage of first. Process which have the shortest burst time are scheduled first. The process which have shortest burst time, this is a shortage of first scheduling. Okay, but next, shortest remaining time first, SRTF. It is primitive mode of SJF algorithm. It is primitive mode of SJF algorithm in which jobs are scheduled according to the shortest remaining time. The remaining time is short, then it is called as shortest remaining time first. Next is round robin scheduling. Each process is assigned a fixed time in a cyclic way. That is called a round robin scheduling. Next is priority based scheduling, non-primitive. This is also called as non-primitive. In this scheduling, processes are scheduled according to their priorities. That is, highest priority process is scheduled first. If priority of two processes match, then scheduling is according to the arrival time. That means the priority based scheduling is depending upon the priority. Next is highest response ratio. Next, that means HRRN. In this scheduling, processes with the highest response ratio is scheduled. This algorithm avoid starvation. That means response ratio is equal to waiting time plus burst time divided by burst time. Next is multi-level queue scheduling. According to the property of processes are replaced in the different queue. Generally, high priority processes are replaced in the top level queue only after completion of processes from top level queue. Lower level queue processes are scheduled. Next is multi-level feedback queue, that means MLFQ scheduling. It allows the process to move in between queues. The idea is separate processes according to the characteristic of CPU burst. If a process uses too much CPU time, it is moved to a lower priority queue. Now, there are some useful facts about the scheduling algorithm. First fact is FCFS can cause long waiting time. Second is especially when the first job taken too much CPU time. Second is both SJF and shortest remaining time. First algorithm may cause starvation. Consider a situation when a long process is there in the ready queue and shorter processes keep coming. Next is if time quantum for round robin scheduling is very large, then the behaves some FCFS scheduling. Next is SJF is optimal in the terms of average waiting time for the given set of processes. SJF gives minimum average waiting time, but problem with SJF is how to predict the time for a next job. Next is the critical section problem. Critical section means the portion of a code in the program where shared variable are accessed and or updated. Next is remainder section, the remaining portion of a program excluding a critical section. Third is race around condition. The final output of the code depend on the order in which the variable are accessed. This is the term as the race around condition. Next, a solution for a critical section problem must satisfy the following condition. First condition is mutual exclusion. That means if a process Pi is executing in its critical section, then no other process is allowed to enter into critical section. Second is progress. If no process is executing in the critical section, then the decision of a process to enter critical section cannot be made by any other process that is executing in its remainder section. The selection of the process cannot be postponed identically. Next is bounded waiting. There exists a bound on a number of times another process can enter into the critical section after a process has made request to access the critical section and before the requested is granted. Next is synchronization tool. A semaphore is an integer variable that is accessed only through two atomic operations, wait and signal. An atomic operation is executed in a single CPU time slices without a permission. Semaphore are two types: counting semaphore and mutex. Counting semaphore. A counting semaphore is an integer variable whose value can range over an unrestricted domain. Next is mutex. A mutex provides mutual exclusion. Either producer or consumer can have the key and proceed with their work as long as buffer is filled by producer. The consumer need to wait and vice versa. At any point of time, only one thread can work with the entire buffer. The concept can generalize using semaphore. Misconception: there is an ambiguity between binary semaphore and mutex. We might have come across that a mutex is a binary semaphore, but they are not. The purpose of mutex and semaphore are different. Maybe due to similarity in their implementation, a mutex would be referred as a binary semaphore. Thank you students for watching my video lecture.